In this video, we'll look at models for statistical simulation. This video will start with a relatively simple model for a single population, and we'll build more complicated models in later videos. Suppose you're playing cards with some friends. The person, or dog on your left, keeps getting cards that are all clubs, and you're a little suspicious. You think maybe the deck isn't fair. So we'll use some statistics to figure this out. In inferential statistics, our goal is to make an inference about a population parameter based on the statistic in a sample. In this case, the parameter you're thinking about is the percent of cards in the deck that are clubs. The issue is that there is sampling variation. That is, if we used one deck of cards and dealt one set of 7 cards, and then dealt another set of 7 cards, then each set would tend to have different numbers of clubs. In order to investigate your friend's cards, we need to quantify the amount of sampling variation. And the way we do this is by simulating many repetitions of the survey or study. This simulation involves making a model for the population. A model is a simplified quantitative or behavioral description of what we think the population looks like. This sounds a little complicated, so let's look at an example. We're interested in your friend's deck of cards. This is the population. And to make a model, we need to specify the variable and parameter. First, we'll choose the variable. That is, do we care about the suit of the cards, the values of the cards, ace through king, the color of the back of the cards? Are they blue, red, or Elvis colored? What do you think? In this case, your friend kept getting lots of clubs, so we're going to focus on the suit. Next, we need to specify the parameter. We could look at the percent of all cards that are clubs, or the percent that are diamonds, or hearts, or spades. In this case, your friend kept getting clubs, so we'll focus on that suit. Then we need to specify a value for the parameter in our model. That is, we could specify that 25% of the cards are clubs, or 50% of the cards are clubs, or 10%, or any other percentage. Now, you might be thinking, aren't there 4 suits, so 1/4 or 25% of the cards should be clubs? And if the deck was fair, that would be the case. But we don't know that the deck is fair. And since we're making a model, we can choose what the model looks like. So let's make models for all 3 of these options. Now, a model could be physical. For example, you could use 4 actual playing cards, as long as 25% of them represent clubs. So it doesn't matter if you have all 4 suits, as long as 25% are clubs. You could use a spinner, as long as 25% of the spinner represents clubs. Instead of physical models, you could also use a computer model. This takes the form of a list of values. For example, here is a list of 4 values, and 25% of the values correspond to clubs. So this is a model for a population of cards where 25% of the cards are clubs. And then to make a model of a deck where 50% of the cards are clubs, you would use a list like this, because 50% of the values in the list are clubs. And for a model where 10% of the cards are clubs, you could use a model that looks like this, because 10% of the cards are clubs. Once you have built the model, then you can use a computer to simulate drawing many sets. Let's do this with the 25% model and simulate drawing a hand of 7 cards. And there's going to be one slight deviation from reality here. We're going to sample with replacement. That is, after a card gets drawn, it gets put back in the deck and the deck is shuffled. This doesn't always happen when playing card games, but we're going to do that here. We'll start by building our list. First, we'll add a club, and then 3 non-clubs to our list. Now we have our model that corresponds to a deck with 25% clubs. And we'll let the computer simulate randomly selecting 7 cards from this model. So in this simulated hand, we only had 1 club. But simulating one hand alone doesn't tell us how much sampling variation there might be from hand to hand. But what we can do is to use the computer to simulate repeatedly drawing many sets of 7 cards from the model and counting the number of clubs in each set of 7 cards. Now we have simulated drawing 1,000 sets of 7 cards from the model, and we could have easily drawn 100,000 or even 1,000,000. And now we can make a histogram to look at the distribution of the number of clubs in each 7-card set. Now each item in this distribution is one set of 7 cards. And what is particularly important is that this is all made by assuming 25% of all cards in the deck are clubs. And this sampling distribution shows us how likely it is to get a set of 7 cards that has 1 club or 4 clubs. Now, let's take a look back at the overall process we used. Our goal was to make an inference about a population parameter based on the statistic in a sample. To do this, we needed to specify what variable we're looking at, the parameter we care about, and the value of the parameter that we're hypothesizing. In our example, we hypothesized that 25% of the cards in the deck are clubs. Then we created a model to reflect this hypothesized parameter value. In our case, a list, where 25% of the list items were clubs. And then we used a computer to simulate repeating the sample of sets of 7 cards based on this model. And this overall method will be central to the way we make statistical inferences.